So solving equations with trig in it requires a different way of thinking. It's not like solving a simple algebraic equation. So here we have an equation, sine of x equals 1/2, and I've graphed the sine of x here and the line y equals 1/2. So when they hit each other, that is a solution to the equation. So you'll notice that they hit each other at several points. And this goes off for infinity in both directions. So it goes to the positive side and the negative side. Another thing you should notice, let me get a brighter color in here, is that the distance between, like, say, this answer that's on the upswing of the curve as we're moving from left to right is similar to this answer this distance apart. Now this distance, because it's repeating after a certain period, is the period of the sine function, which is 2 pi. So every 2 pi, we're going to get a related answer. And the same thing is going to happen with the second answer. 2 pi away from it is going to be another answer. And if we go backwards to here, this would be negative 2 pi away. So whether we go positive 2 pi or negative 2 pi, there's always going to be another answer of the sine of x equals 1/2. All right, to solve it then, what we're going to do is use pictures. First off, the sine is positive 1/2, so that happens in two of the quadrants. So I'm going to draw a picture. It's positive in the first quadrant. I usually call this my main triangle. And sine is also positive in the second quadrant, and that'll be my secondary angle. So if sine of x is equal to 1/2, then the sine of x is opposite over hypotenuse as a ratio. So if this is my answer, which is x, the angle x, then opposite is going to be 1, hypotenuse is going to be 2. The third side, if we really need it, is square root of 3. It's a special triangle. That makes this x definitely equal to pi over 6, 30 degrees. So if this x is 30 degrees, then this one over here is also 30 degrees, pi over 6, as a reference angle. So the only thing we need to measure is how far is it from here to here to come up with the answer for x. So that distance is going to be, remember pi over 6 is 6 pieces in the top, and we're losing one because we're backing off this pi over 6, so that makes it 5 pieces out of 6. So 5 pi over 6. So my secondary answer is 5 pi over 6. All right, now that takes care of two things. And the two things it takes care of is the first two answers in a single rotation of sine, of the sine curve. So we've found this answer here, that's the pi over 6, and this one over here is 5 pi over 6. If I want to represent the rest of the answers, like I was saying earlier, is it's 2 pi away. So the first thing I'm going to do is add 2 pi to both of them. But then earlier I said, well, it's 2 pi away to get to this answer for the pi over 6, another 2 pi to get to this answer for the pi over 6, and the same thing for the other dots for 5 pi over 6. So it's happening once, twice, maybe 3 times. So I'm going to multiply it by a constant. And we're going to call this k the counter. And k is an integer. And this is a way of representing all the possible answers of this equation. And since k is an integer, it takes care of the negative numbers, 0, and the positive numbers, off to infinity. So that represents all possible answers. So it's pi over 6 plus 2 pi, pi over 6 plus 4 pi, pi over 6 plus 6 pi, and while we're at it, we can go pi over 6 minus 2 pi, and so forth and so on. So this becomes all possible answers for this equation. Now, if sometimes you just want the first rotation, the first period of the function's answer. So 2 pi only brings us up to not that point. 2 pi of the original curve only brings us to here. That is one period of a normal sine function, starting at 0, going high, middle, low, middle. Stopping at the x-axis, not the blue line. So if we want just those two answers, then it's our main answer, pi over 6, and our secondary answer, 5 pi over 6, without the 2 pi k. So it depends on how the question is worded. Does it want answers between 0 and 2 pi? If it says something like, my answer is between 0 and 2 pi, then the only solution set for this equation is pi over 6 and 5 pi over 6. If it just asks for all answers, then your solution set is going to be pi over 6 plus 2 pi k. The book might use n. K and n are the same thing. And then the other one would be 5 pi over 6 plus 2 pi k. Now this 2 pi k is going to become a little trickier later when we start changing the periods of this, the graph itself. Sometimes when working with an equation, you have to kind of get it into the right format. So this equation, square root of 3 plus 2 cosine of x is equal to 0, is not in the format that we need. So we're going to use a little bit of linear quadratic or polynomial solving equations styles for some of these. And the first thing we need to get by itself is the cosine of x. So I want to isolate the trigonomic function and get all the numbers to the other side. So if I do that, I'm going to get cosine of x is equal to negative square root of 3 over 2. All right. So we need to find when cosine of x has a negative ratio. Now, to find that, we're going to draw our picture. And remember that it's all students take calculus. So what quadrants is cosine negative in? Well, it's positive in the first quadrant. It's definitely negative in the second quadrant, and it's definitely negative in the third quadrant. It's positive in the first and the fourth. So when I draw my pictures for this function, this equation, I'm going to draw the main one in the second quadrant. And the reason it's the main one, I forgot to say this in the last time I was drawing a picture, is cosine inverse works in the second quadrant, not in the third. So I call it the main one because if you use your calculator, these are where the answers are going to lie. And it's always important to know where your angle is. All right, so if I label my sides, cosine being adjacent over hypotenuse, caught another hippie, then this side is square root of 3, this side is 2, and this side is 1, and the negative has to go on the square root of 3 because it's going to the left. So that makes this reference angle pi over 6. Okay. But that's not the angle of the solution. The solution always has to start at the positive x-axis and open up to where your terminal side is. So if that's pi over 6, then this is 5 pi over 6. So our main answer for this equation is 5 pi over 6. Now the secondary solution is down in the third quadrant. So to go from the positive x-axis into the third quadrant with a reference angle of pi over 6, you just have to remember that there's 6 pieces on the top, for the up to pi, and then you're going one more. So that would be 7 pi over 6. So if we're looking for answers between 0 and 2 pi, then those two answers would be 5 pi over 6 and 7 pi over 6. If we were looking for all solutions, then our answer would be 5 pi over 6 plus 2 pi k and 7 pi over 6 plus 2 pi k. again, k being an integer, counting up all the possible answers one period away from each of these answers. And that's it. Pretty easy. So here's a more complex equation. It kind of looks like a quadratic, and that's pretty much how you should treat it. One problem with trigonomic functions is you really can't solve an equation with two different functions. So we're going to have to convert one into the other. Now sine x, we're definitely not going to be able to convert into cosine, but it is possible to change cosine squared x. So to do that, we're going to change it using the Pythagorean identity. Cosine squared is equal to 1 minus sine squared x. And that way we're dealing with the same function, sine of x. All right, and now since we're going to treat this like a quadratic, I'm going to get rid of the parentheses and get everything on one side of the equation. So distribute the -2 and move the sine x over and get it equal to 0. All right, and then just combine like terms and then order the polynomial looking thing. So if we order it, the sine squared should come first. The sine x should come second. And if we combine the -2 and the 1, we'll get a +1, and it's equal to 0. If you don't see that this is factorable, you can use the substitution trick, let u equal the middle term, which in this case, without the coefficient, is sine x. So if you let u equal sine of x, then u squared is going to equal sine squared of x, and you can change the equation to be 2u squared minus u plus 1 is equal to 0, and that way you can see how the factors work. So here we're looking for factors of 2 that add up to a -1. So if we do that, this is actually kind of a simple factoring. The way to get 1 at the end is to have 1 in both of these locations. To get a 2 in the beginning, you only have one choice, to put the 2 there. They're both going to have a u here and here, and then you just have to decide how to get a -1 in the middle. We need the 2 to be the bigger number negatively. So when we multiply the out and putting the negative there, we'll get -2, and this will give us +1u, and that'll give us the -u. So this is equal to 0. So we're going to get u equals -1/2, setting the factors equal to 0, and u equals 1. So if we go back to our original equation, this should be sine of x, because remember, u is equal to sine of x at the top. So we're going to do a resubstitution. It must be equal to -1/2, and this u equals to 1 would be sine of x must also equal 1. Now you could have factored just in terms of sine of x instead of switching to u. It's what I usually do, but if you don't see how it factors, this orange part is a good way of doing it. All right, so for the first equation, we just have to remember that sine is opposite over hypotenuse. -1/2 will give us a triangle. In the second equation, because this is equal to 1, which is the maximum that a sine is going to obtain, this one is, you find the answer by the unit circle. And a lot of people forget that. They try to draw a triangle with 1, and it's not possible. So if we're going to draw a triangle, we want to know when sine is negative. So I'm going to kind of shorthand this one. Sine is positive in the first quadrant. It's positive in the second quadrant, all students. So it's negative in the third, and it's negative in the fourth. Take calculus. The main angle, remember I go by main angles where sine inverse works. The main angle is going to be in the fourth quadrant. And then the secondary angle is going to be in the third quadrant. All right, and then label your sides. Opposite is 1, hypotenuse is 2. It's a -1 because it's going down. The third side is square root of 3. Oh, it's another pi over 6. So this is going to be pi over 6 as a reference angle. Now be careful of that. The answer is not pi over 6 because that would be in the first quadrant. So either the answer is negative pi over 6, which some people don't like using negative angles. So the other possible answer is you have to wrap all the way around. So if we're going to wrap all the way around, this is 6 pieces to get to here. It's 12 pieces to get to here, and then you have to back off 1. So if you do 12 pieces and back off 1, one of my answers is going to be 11 pi over 6. Or the same as negative pi over 6. Now my other answer is going to be in the third quadrant. So that's 6 pieces and 1 more. So if you do 6 pieces and 1 more, that's going to be 7 pi over 6. So all of the answers would be with that 2 pi k thing. And then if it was just one rotation, this one equation will give us these 2 main answers. All right, the other one is on a unit circle. So if it's on a unit circle, it's an ugly unit circle, and this is 1, 0, and this one is 0, 1, and this one over here is negative 1, 0, and down here is 0, negative 1. So 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and then back to 2 pi. All right, so when is sine of x equal to 1? Now, you only have to remember that sine of x is the y coordinate. So here sine of x is equal to 0. Here sine of x is equal to 1, 0, and negative 1. And we're looking for positive 1, so our answer is pi over 2. So if we're just looking for 0 to 2 pi answers, then they are going to be, arrow, x equal to the set of answers of 11 pi over 6, 7 pi over 6, and pi over 2. And then, of course, you could add on the plus 2 pi k to each of these for all the possible solutions to this equation. So here's where the plus 2 pi k gets a little tricky. You kind of solve it the same way, and I'm going to do this in a 2-step process. So here the equation says tangent of 3x is equal to negative square root of 3. What I'm going to solve, though, is tangent of what angle is equal to negative square root of 3. And then, I'm basically substituting theta for 3x. And I'll get back to the x later on. So again, we're going to be saying, when is the ratio of tangent equal to a negative? Remember, the tangent ratio is tripping on acid, so it's opposite over adjacent. So I might as well put a over 1 there to see the ratio. So tangent is negative if we're looking at the quadrants, and we have, all students take calculus. Tangent is positive in the third quadrant and first. So the quadrants we're looking for are second and fourth. So that's where I'm going to draw my pictures. So if I draw my picture in the second and the fourth, the main one, because of tan inverse, is actually going to be in the fourth quadrant. And the only reason I do this is in the next chapter you have to worry about where an inverse function is going to work. All right, so tan inverse is in the fourth quadrant. Its ratio is opposite over adjacent. So this is negative square root of 3. This side is 1, this side is 2, and the main reference angle is pi over 3. Now remember, pi over 3 itself is in the first quadrant. This is a reference angle. And then my secondary angle for tangent is in the second quadrant. And one thing that's cool about tangent is instead of having your answers wrap around 2 pi, the period of tangent is pi, and it works out perfectly even to find the secondary answer, because that's a pi rotation, it's a straight line. So once I come up with one of the answers, you technically have all of them. So here my main angle, if we start in the positive x-axis and wrap around positively to this location over here, this is a pi over 3, so there's 3 pieces in the top, and then you have 3 more pieces in the bottom, but you're going to back off 1. So that's 6 all the way around, backing off 1, that's 5 pi over 6. So I know theta is equal to 5 pi over 6. And then if we add in here pi k, that's going to represent all the answers. Because remember, this angle that goes from the fourth quadrant to the second quadrant is just a straight line, and that's just adding on pi. So if we go to 5 pi over 6 and we add pi, we're going to end up here in the second quadrant. And if we subtract pi, we're going to end up in the second quadrant also. So both ways give me to the secondary answer. And then if I just keep adding pi k, I'll just bounce back and forth between these two solutions forever. But theta is not what we were solving for. We were solving for 3x. So I'm going to change theta into 3x equals 5 pi over 6 plus pi k, and solve for x. So that means I have to divide by 3. But because I have a fraction involved here, I'm going to use a trick called the multiplicative inverse, which means I'm going to multiply by 1/3. So if I multiply by 1/3 every single term, let me get this mess. Go back to purple. And, 1/3 times 3 is 1, so we'll get x. 1/3 times 5 pi over 6, you just have to multiply top and bottom. So you get 5 pi times 1, 6 times 3, and then over here you're just going to get pi k over 3. All right, now it makes it easier if you can get a common denominator before doing the next step. So I'm going to rewrite this as 5 pi plus, to make the 3 and 18, I just have to multiply by 6, top and bottom, and I get this expression. So if I'm asked for the answers between 0 and 2 pi, then what I'm going to have to do is let k cycle through a few numbers, because that 18 is going to take a while to get all my answers. So I'm going to let k equal 0, and my solution set for k equals 0 is going to be the original 5 pi over 18, if k is equal to 0. If k is equal to 1, then I'm going to get 5 pi plus 6 pi over 18, better known as 11 pi over 18. If I let k equal 2, that gives me 12 plus 5, which is 17 pi over 18. If I let k equal 3, that gives me 18 plus 5, which is 23 pi over 18. And you're probably wondering, when should I stop? Well, I have to stop when the top becomes bigger than 36, because that's twice 18, which would be a representative of a 2 pi. And I'm not there yet, so k equals 4. 4 times 6 is 24. 24 and 5 is 29 pi over 18. And if I let k equal 5, that's 35 pi over 18. Oops, 35 pi over 18. And then you can kind of get the hint that the next one's going to be too big, because 36 pi over 18 would be 2 pi, and then you would be adding on a little bit more. All right, so these are the solutions for x for one rotation. This is the solution for all x's, letting k being any integer. So the other option of solving a trig equation, especially in this example, would be using a calculator. And it gets a little different when you use a calculator, because you have to be really cautious, because calculators will just spit out answers and you have to be able to interpret them. So again, we're going to have to get secant, the trig function, by itself. So we'll subtract 5 and divide by 3. So we'll get secant of x is equal to negative 5/3. Being larger than 1 for secant is actually pretty good. It's not good for sine and cosine, because the maximum, of course, is 1. But this is perfectly fine. And the ratio for secant, being the reciprocal of cosine, is going to be hypotenuse over adjacent. So I highly suggest you still draw the picture because, again, the calculator is just going to spit out an answer and you have to be able to come up with all the other possible answers. So if we're looking at secant, which is the reciprocal of cosine, and we're looking for a negative ratio, then cosine is negative in the second and the third quadrants. So my main triangle for cosine inverse is going to be in the second quadrant. So when I draw my picture, even though it's not going to give me a special triangle, I still want to put my main triangle in the second quadrant. And then use the calculator to come up with the answer. So the calculator is actually going to give us this answer, the main angle from the positive x-axis to that terminal side. Now, to type secant as an inverse into a calculator, you're going to have to actually use cosine inverse. And you're going to have to reciprocate hypotenuse over adjacent to be adjacent over hypotenuse. So the equation secant of x is equal to negative 5/3 is the same thing as cosine of x is equal to negative 3/5. And then when I cosine inverse both sides, I'll get x by itself. So this is the same thing as cosine of x is equal to negative 3/5. And sometimes that's easier to get away from secondary trig functions to the main trig functions, the reciprocals. All right, so in the calculator, I'm going to type in cosine inverse of negative 3/5, and I'm going to make sure that I do this in radians. Arc cosine of negative 3/5. Let's be really safe with it. There we go. It's going to give us some ugly decimal. Now this thing is in radians, so 2.214. I'll go about that far. 2.214. So this is approximately 2.214, and I'll put rad just to remind myself that's in radians. So that's what this angle up here is. And again, that's the main angle. So the secondary angle is going to be in the third quadrant. Now to find its opening up measurement, it's going to get a little trickier. Number one, we have to figure out what the reference angle of this triangle is. And to find that, we're going to subtract this angle from pi. So it's going to be pi minus 2.214. Because pi is a full out opening, and then we're trying to back off to see what's left over. All right, so pi minus 2.214. So let's see here. Minus pi. It's going to come out negative, which is fine. I'll just ignore the negative. So it's going to be 0.927. So this is approximately 0.927 radians. So this is my reference angle. Let's call it theta. So this angle up here is theta. So if that's the reference angle of that triangle, then if I draw a triangle down here, that's also the reference of that triangle. So to get to my second answer, it's going to be pi open to here, and then I just have to add on the theta that I just found. So it's going to be pi plus 0.927 radians. We'll see what that. 4.069. Okay. So when I get down to it, I'm going to have x is equal to two ugly answers. First ugly answer is 2.214. Second ugly answer is going to be 4.069. And then if you want all the answers, remember this one's just between 0 and 2 pi. If you want all the answers, then it's going to be 2.214 plus 2 pi k and 4.069 plus 2 pi k. So when they're calculator answers, it's still really important to draw the picture to figure out what these angles are going to be.